The biggest shift here is that image generation is becoming far more controllable without the usual retraining tax. One system learns to move smoothly across resolution scales inside a single diffusion process. Another injects visual references at inference time, and a fully open model shows you can still close a lot of the gap to proprietary stacks with the right recipe. That matters because the bottleneck is no longer just, can the model generate? It's now, can it preserve structure, obey a prompt, and adapt to new guidance without a costly fine-tune? Keep watching, because the interesting part is how these papers quietly redefine what flexibility in diffusion models actually looks like. Let's explore the first paper. Everything at every scale, scale invariant diffusion with continuous super resolution. This MIT-led paper introduces Skilled, a scale invariant case-based image learning diffusion model that makes image scale an explicit diffusion coordinate by attenuating high-frequency DCT modes before low-frequency ones while injecting spectrum-matched Gaussian noise. So one unconditional reverse process can do both generation and continuous super resolution with no task-specific conditioning, classifier-free guidance, or per-scale retraining. On CFAR 10, the model reaches FID 2.65 and inception score 9.63, making it the strongest among the frequency-informed diffusion methods compared in the paper. The same checkpoint then performs continuous ImageNet super resolution from 2 times to 8 times, and at 4 times on ImageNet 256, it achieves the best LPIPs at 0.186, Clipica at 0.612, and Music at 59,226, while remaining competitive on PSNR and SSIM. The authors also validate the scale invariant mechanism on a 128 times 128 critical 2 de-Ising benchmark, where reconstructions from a 32 times 32 effective resolution start preserve the connected 4-point correlation kappa 4 across patch sizes far better than SR3. The key novelty is that the forward process preserves the dataset's empirical power spectrum, which the paper shows follows an approximate k-2 law across CFAR 10 and ImageNet, allowing super resolution to be interpreted as starting the same diffusion trajectory from different time steps. Let's explore the second paper, injecting image guidance into text-conditioned diffusion models at inference. The paper introduces visual concept fusion, a training-free inference time method for injecting reference images into text-conditioned diffusion models such as Stable Diffusion v2 without retraining the generator or concept-specific fine-tuning. The core idea is to align clip image tokens to the clip text token manifold with a lightweight 2-layer MLP trained on only a 10% subset of COCO captions, then fuse aligned image and text tokens through concatenation, naive blending, or cross-attention. An optional prompt noise optimization module further refines the initial DDIM noise and conditioning tokens. Using Stable Diffusion v2, 1 at 768 times 768 with 50 DDIM steps. The method preserves prompt semantics while transferring style, composition, and color palette from the reference image. Quantitatively, the main trade-off is between clip text alignment and LPIP's reference similarity. Text-only SDV2 scores 0.29 clip and 0.78 LPIPs, naive fusion scores 0.28 and 0.77, and VCF reaches 0.27 and 0.76, indicating stronger perceptual adherence to the reference at a modest cost in prompt literalism. The aligner is lightweight, trains in under 2 hours on a single A100 GPU, and ablations show that combining InfoSense with cross-attention reconstruction is necessary for balancing global semantic alignment and local visual detail. Prompt noise optimization further reduces noise and improves fidelity to reference-specific features. Let's explore the third paper, I1A, Simple and Fully Open Recipe for Strong Text-to-Image Models. I1 from Princeton University is presented as a simple and fully open text-to-image diffusion recipe that closes much of the gap to proprietary systems by combining 300+ controlled experiments and 700K plus TPU v6 e-hours into a 3B parameter model trained only on public data. The paper shows that several seemingly standard choices are not necessary or are suboptimal. A single strong text encoder, T5 Gemma, 2B, paired with a larger 2 transformer block adapter is more effective than stacking multiple encoders. 8L noise, time step conditioning adds little and is removed, and dual stream MMDIT with long skip connections gives the best performance parameter trade-off. On the data side, long synthetic captions from Quinn3V L30BA3B outperform short captions, but require inference time prompt rewriting to recover performance on short prompts. Equal weighting across datasets is a strong default, and repeating a diverse dataset causes only marginal degradation. The final I1 model uses public datasets, 2M low-resolution training steps, 0, 5M at 512 resolution, and 0, 3M at 1024 resolution, then reaches 86.73 DPG bench, 70.1 prism, 0.8531 CVTG, 2K, and 0.922 long text bench, outperforming the best prior fully open model by 29.5 absolute points on average across 5 benchmarks. That's a wrap on today's AI paper highlights. Thanks for watching.